Okay, good afternoon, everyone. Today's video, we're going to talk about exponential growth and decay. So there's a couple things that you need to be mindful about. You have exponential growth if it's in the form of something like f of x equals a times 1 plus r to the t. That's growth. Now, what is this? A, this is kind of like this is like your initial value, and then this 1 plus r. This the 1 plus r, that is pretty much um, that that's the plus an interest rate. That's exponential growth. That's growth. Okay, and then exponential decay would be, actually, I'm gonna move that t. F of t equals, how about a, and if you're subtracting, and this is going to be decay. So that's your exponential decay. So realistically, T is going to be time and R is going to be your growth rate. So if you look at your, like, if you look at, like, probably problem number one, something like this right here, where it says Brooke started her career with an annual salary of 32,000. Each year thereafter, the salary increased 2.5%, right, in an exponential growth function, and then find her salary when she retires after 30 years. So I'm actually going to be doing the odds so you can follow along in the book, so, or in your packet. So with this, for problem number one, Brooks' initial salary is 32,000. So I'm putting that in for A. And then I'm going to go 1 plus an increase of 0.025 because it's 2.5% per year. So I'm going to take that to the t, and that's going to equal my function. Okay. Now they want to know when she retires after 30 years. You literally have this, and you take it to the 30th power. So you punch that in the calculator, and when you do that, you get something like $67,122.16. All right. So you can do number two. Number three, it says something like Kate drank on an energy beverage with 150 milligrams of caffeine. Each hour, the amount of caffeine in her system decreases. So what does that mean for, like, number three? Decreasing. Well, you start with 150 milligrams, and this is going to be one minus the 12%, so 0.12 taken to the t, and that's equal to f of t. When you take 100% minus 12%, it leaves you 80%, so you get 150, and it's going to be 0.88 to the t. And they want to find out how much time after, was it 8 hours? So you're going to do 150.88 to the 8. And when you punch that into your calculator, I think you get 53.95. So 53.95 milligrams of uh, coffee. All right, that covers that. Let's talk about something else. So that's exponential growth and decay. Okay, when we talk about continuous growth, that uses our transcendental number E. So when you talk about continuous growth, right, where it means that it grows every um, hour of the minute of the day, right, you're going to use what we call uh, the PERT formula. So that's PE to the RT. Okay. So if they say that it grows uh, continuously, you're going to use that. P is your starting value. E is the number on your calculator, and R is the interest is the rate as a decimal, and T is time. Okay. So if you look at number five, a garbage dumpster started with 4 pounds of garbage. The amount of garbage increased continuously by 35% each day from this point forward. And then how much garbage in 2 weeks. So our formula is A equals 4, because that's what we started, E to the 0.35 T. Now, T in this case is days. So we're going to actually punch in 14 here. And when you punch it into your calculator, you get 537.16 pounds. Okay. So you guys can do number six. If it says it declines, instead of having a positive rate, it's going to be a negative rate. So if it declines, it's going to be a negative, and you're allowed to do that. Okay. What I want to talk about next is what's called a logistic growth function. The logistic growth function is when a quantity exponentially increases but then kind of mellows out. This would be like your limiting factor in biology, I believe. So the graph looks like in your chart there, it looks a little weird, but it basically approaches an asymptote. So now, the logistic growth function looks like this. So it's c divided by 1 plus ae to the negative rx. Now, what is c? C would be your asymptote, right? And a is the amount that they give you, and the rate is going to be as a decimal. So let's look at like number 7. It says a disease begins to spread in a town of 20,000 people. After T days, the number of people who have been infected by the disease is modeled by the function below. Use the function and find the number of people infected after 10 days. So they gave us this function for number 7. So we're not worried about the graph. The 20,000 is the limiting factor. That says most people that you can have, and then it grew by or you're losing like 5% of your people. All right. So when they say 10 days, all you're going to do is put 10 in for T. The hardest part about this, punch it in the calculator. And when you do that, this comes out to be about 1,800 or 18,415 people. Okay. And I just realized that, yeah, there you go. So it comes out to that. You can do number 8, and that covers exponential growth in decay. So pause the video, try some of the problems, and I'll see you tomorrow in class, and may the force be with you.